Today, on how it's made. Hot rods. Decorative eggs. Fire hose nozzles. And baseballs. A hot rod is a normal car that's been radically modified to look snazzier and drive faster. Some amateur mechanics tinker away at building one in their garage, while other car buffs custom order one from a specialty auto shop. Either way, hot rod lovers are driven by their passion for these mean machines. Hot rods are customized inside and out. The classic cars they start out as are pretty scarce these days, so specialty shops now design and build hot rod bodies from scratch, using state-of-the-art technologies. It all starts with curved steel rails, 4.5 meters long, that form the basis of the chassis. Every 30 centimeters, workers weld the rails to the car's frame. Next, they position cross members to reinforce the frame. With utmost concern for quality control, they'll assemble and install by hand the transmission, the suspension, and the shock absorbers, and weld those precisely aligned cross members to the curved rails. Elsewhere, someone polishes the stainless steel wings, which have been laser cut. These wings make up the hot rod's signature front grille. Mounting the disc brakes onto such a high-end machine takes specialists. First, they screw the spindles to the suspension arm. Then grease the ball bearing mechanism. And finally, block the disc brake with a cotter pin to fasten the pieces together. The brake system has 4 calipers, 1 per wheel. Each one holds 2 brackets, called the brake shoes. They close down on the brake disc to slow down and stop the wheel's rotation. A couple of slide pins lock the caliper into place. Brake shoes are prone to wear, so their alignment and oiling must be perfect. The time has come to install a hydraulic device that reacts to the steering wheel's movement, directing the tie rods to turn the front wheels accordingly. A pneumatic tool is used to affix the pinion of the steering mechanism. At every step, workers carefully check and double-check each part. Using a jack, they lift the differential housing into position. It anchors the rear wheel's propulsion system to the car's frame. They attach the suspension arms to the axles at an angle. Meanwhile, a painter sprays a coat of resin gel onto the plastic molds with which they make the car's fiberglass body parts. The gel coating eases extraction and gives the fiberglass a high-gloss finish. To mold the parts, a worker spreads resin on fiberglass cloth. They call this step wetting the fiberglass map. They lay the map on the mold, in this case, a door mold. Then, with a roller, carefully press out all the air bubbles. It takes about 40 minutes for the resin-impregnated map to solidify. Extracting the body part is a tricky procedure. They hammer wood wedges in between the hardened fiberglass and the mold. It's crucial to angle the wedge just right. Otherwise, the mold may collapse. It typically takes about 25 molded parts to make up a complete hot rod body. After 3 weeks' work, final assembly begins. After the back panels comes the front, otherwise known as the nose. Next come the fenders, then the stylish running board. And no hot rod is complete without its signature grille. The windshield frame helps support the roof, or Carson top in hot rod lingo. The front hood completes this 37 Ford-inspired body. It ships without a paint job. That's because customization is everything in the hot rod biz. The buyer decides how to finish the car by choosing, for example, this retro dashboard designed to blend spectacularly with the rest of the car. Even car junkies can be forgiven for struggling to keep up to speed with the ever-growing customization options out there. From the engine, to the rims, to the seats, to the chromes, when it comes to customizing your hot rod, you're in the driver's seat. Egg decorating is a craft practiced around the world for centuries. The ancient Persians painted eggs for Nowruz, their New Year celebration, a tradition that continues today. Probably the most famous are the exquisitely decorated Fabergé eggs, except they aren't eggs at all. They're made from precious metals and gemstones. Each one of these decorative eggs is a unique piece. The artist paints them, collages images in fabric, and creates jewelry and music boxes, or hangs them as ornaments. She always works with real eggs, from birds like the rhea, the emu, geese, or turkeys. Here she selects an ostrich egg and gently clamps it in place on an egg marker stand. On the underside of the stand are a series of guidelines to help divide the egg into 2 or more equal parts. Working with a pencil held in a brace, she divides the egg into 4 equal parts. Then she draws a horizontal line across the egg where she'll cut it in half to create a lid. She'll use a hinge to hold the lid in place. So first, she draws the contour. Then a loose wavy line all along the egg circumference, using the pencil guidelines as reference. A rotating cutter equipped with a diamond-dusted blade makes a cut where the hinge will be. The artist now prepares some 5-minute epoxy glue. She has a neat trick to apply just the right amount. She works with a strand of uncooked spaghetti, then sets the hinge in place. Once the hinge is set, she cuts all around the egg, then opens and closes it to make sure that hinge works properly. It's the first time she sees the egg's interior. If it needs cleaning, now's the time. Though this artist often chooses to leave ostrich eggs their natural color, here she's decided to give the lid a thin coat of acrylic paint. For the lower half, she chooses a darker tone. Acrylic paint allows her to work quickly, as it dries in just a few seconds. Next, she uses a special glue to collage strips of Japanese rice paper onto the egg. She layers small pieces to achieve a tortoiseshell finish. She's ready to set the egg on its stand, so she coats the rim with epoxy, then sets the egg down, making sure the hinge is level with the stand's rim. The artist now turns her attention to the egg's interior. She lightly glues perfumed cotton balls to fill out the top and bottom parts. Then she applies glue along the inner rims and clips on a piece of ivory satin. By the time she makes it around both halves, she can remove the clips. The fabric now holds firmly in place. Next, she glues a fabric braid to trim the satin's edge. Here the artist lays down a delicate strand of rhinestones. She applies more glue to add another braid along the lower rim. Then places a final strand to complete the effect. She sets in a tiny rhinestone to decorate the metallic filigree that hides the hinges. Even the egg's underside gets special attention. She glues another filigree to cover the hole through which they empty the egg, then applies a water-based varnish. This strengthens the egg and gives it a glossy finish. Here's the finished piece, a delicate jewelry box that opens with the help of a fine chain to reveal its satin interior. There's no end to the creativity that goes into making these decorative eggs. This model even has a music box built in. Precision tools that perform their task with split-second speed and accuracy are key in jobs where time is of the essence. Take, for example, the nozzle at the end of a firefighting hose. It allows a firefighter to regulate the pressure of the water exiting the hose, no matter how confined or widespread the flames. A fire hose nozzle isn't a simple point-and-shoot device. It enables firefighters to tailor their tactics by firing water in a stream or flush. Production begins with a long aluminum tube. A saw slices off 16-centimeter pieces called blanks. Just one tube makes about 46 blanks. A robotic arm swoops down to transport them to a lathe. Cutting tools form the valve body, which controls the flow of water. Then they rough up the surface, making it easier to grip. They make a ball groove on the outside rim for attaching the hose coupling. Next, they form the interior. Technicians verify the inside shape with computer imaging software. It's on to the milling process. A computer-guided drill bores several holes for the nozzle and grip attachments. Coolant washes away the metal chips and keeps the drill bit from overheating. The transformation from a blank to a valve body is structurally complete. A laser now engraves the flow indication. Workers install rubber O-rings on a mandrel shaped like the valve body interior. The rings keep water from leaking out the side of the nozzle. They position the valve body over the mandrel and blow the rings into place with a blast of air. Automated machines now mate the valve body to the nozzle's handle. A heated mold melts granulated rubber and casts it into ridges at the top of a rubber cylinder. This makes the shaper, the nozzle's adjustable head that switches the water from a wide spray to a narrow stream. Workers snip off any excess rubber, then ensure the rubber is solidly molded. Next, they apply grease to the inside to lubricate the parts and prevent corrosion. 2 more O-rings are inserted to keep water from leaking out under the shaper. Using a specially designed spoon, they scoop up tiny plastic ball bearings and drop them into a groove in the shaper. These allow the shaper to rotate easily. The shaper then goes over a barrel, a metal tube that helps form the stream of water. To attach it, they apply an adhesive to the threads on the shaper's base, then slide the part into place. Workers insert a pair of hard plastic balls into the shaper. These enable the shaper to glide back and forth on the barrel to shape the water stream. Now it's time to build the sub-baffle, the nozzle component that controls water pressure. First, they insert a pressure regulation spring into the baffle body. Then snap on a knob which changes between standard water pressure and low pressure. The whole device slides directly into the barrel. On the other end of the barrel, they screw on the valve body. A rotating wheel simplifies this process. They now affix a pistol-style grip. Finally, the gasket grabber goes in. The steel screen keeps out nozzle clogging debris coming from the hose. With the nozzle assembly now complete, it's time for what they call a damp run. Workers check everything to ensure the nozzle performs its tasks at every twist and turn. From the old-fashioned nozzle to the modern variety that comes in an assortment of flows, pressures, and sizes, the evolution of the fire hose nozzle is undoubtedly a lifesaver. When they make baseballs for the pros, they aren't just playing around. They build these balls precisely to league standards, and incredibly, those standards date back to 1872. Each ball is uniform in circumference and weight, so the game is an equal contest. Crowds will go wild for these professional baseballs, and at the heart of each one is something called the pill. The pill is smaller than a golf ball. It's about 10.5 centimeters in circumference. Inside the pill's rubber casing is a sphere of cork. They pour latex adhesive over hundreds of pills loaded into a drum. Rollers spin the drum to evenly coat the pills with the adhesive. This adhesive never dries out completely, and the pills remain sticky to the touch. Next, they loop 4-ply wool around the pill. This machine spins the pill to wind the yarn around it. This winding substantially fattens the pill. It's the first time a camera has ever been allowed to record this proprietary machine, so we can't show you all of it. They wind a second layer of wool around the pills. This yarn is 3-ply, and it thickens the ball a little more. For a third winding, they use another 3-ply yarn, but it's a bit lighter. The various layers of yarn are what gives the baseball resilience, so it springs back into shape despite being hit repeatedly. For the final winding, they use a much thinner polywool blend because its surface is smoother. This wound pill is called the center. They weigh it and measure its circumference, which should be 22.5 centimeters. They add adhesive to a spinning drum, then load the centers into it. As the centers tumble, they absorb the glue and the wound fibers adhere to each other. The centers air dry for 48 hours but remain sticky. Using this hydraulic press, they punch out figure-8 shapes from leather, complete with holes around the periphery, allowing them to be stitched into baseball covers. But first, they stamp the date and lot number onto them. Then they wrap them in wet towels. The moisture will make the leather pliable enough to sew. They roll the water-based adhesive onto one side of the cutouts, which sticks to the moist leather. They press 2 cutouts to the center sticky surface. It's an exact fit. They clamp the leather-clad ball in a vise, and it's time to sew. Working with 2 needles, the sewer pulls thread through the ball center and up through the holes in the leather pieces to cross-stitch them together. He rubs wax on the thread to stiffen it, because if it slackens, it's more likely to tangle. When it comes to cross-stitching, these workers are in a league of their own. They make quick work of the 108 stitches in each ball. There are 350 sewers in this factory, and they produce 8,000 to 10,000 balls per day. That's a lot of home runs. The final stitch goes through the center of the baseball and out the other side. The sewer then pulls the stitches into a V configuration to give the ball a consistent look and feel. The balls now roll into a press that smooths down the seams. Smoother balls are harder to grip, and they make pitching a bit tougher for the pros. Finally, a three-headed stamper gives it the trademark, league logo, and the commissioner's signature. With drying cycles, it takes a week to make a professional baseball. It will be whacked and slammed out of the playing field. But that's life in the big leagues.